This is a relatively small intron from human. The features of the fold can be shown by turning off the various switches in King. This switch turns off the unpaired bases. This switch turns off the big stems, and this turns off the small stems. So you see that the structure is composed of three, this particular structure is composed of three features. The big stems, which are between 8 bases and 19 bases, and then the small stems, which are between 2 and 7 bases, and then the loops. So these are the complete structures. Now, the question is, how did this fold actually occur? Well, that's shown in the next series of images. So this is the first determination of a stem of 14 bases. So the beginning of the sequence is here, and the end of the sequence is here, and the algorithm has found one 14 base pair stem. Now, if we go to the animate here, we'll see that now it has found one 13 base stem, and now it's found a 12th base stem. So at any point you can move the image around and look at it. Now we've just added a 11 base stem, and now we've found two 10 base stems. Again, you see the structure is getting more complicated as we do this. Here you see this is including 9 base stems, so the structure is becoming more defined. And here we have 8 base stems, and now we have 7 base stems, 6 base stems. I'll position the structure a bit and zoom up a bit. You can do this easily. And so here you see the structure resolved down to finding the 6 base stems. And now we're on to 5. And again, the way the program works, I have to reposition occasionally. But here are the 5 base stems included. And now we go down and look at 4. I'll reposition once again. So you can see the structure resolving itself. And now this is 3. I'll reposition once again. We can see rather nicely the structure, including the 3 base. And then finally, the 2 base stems are shown in this image. And you can see the structure as we saw it originally. So this is relatively small intron. This is, however, a much larger sequence. And in this sequence, in addition to the loops, which we have here, we have the small stems, which are in white. And now you see there are many, many more intermediate stems called big stems. But in particular, now we see that there are 25 or so dicer stems, which are 20 base pairs or longer. So now if we put back in the big stems and the small stems, you can see how many there are of these. And then the RNA loops, well, this is the complete structure. So this is something that's not been seen before, because it just hasn't been a program that could fold arbitrarily large RNAs. So if we go now to the step-by-step view, here we see that the sequence is by and large unstructured, except the program has found one 56 base stem, and now it has found a 50 base stem, and now a 38 base stem. Okay, so it's working its way down, finding successively smaller stems. Here's 35. Here's 34. Now this procedure is called step by step. So that's exactly what we're doing. We're seeing 32 now, 31. You see, it's developing naturally. 30. The loops are getting smaller, and of course, again, you can see the beginning and the end of the sequence there. 29. So what you're seeing is that the structure tends to decompose in a very, or compose in a very regional fashion, and it's only occasionally when now we have 26. So I'll pick the center here and blow it up a bit, so you can do that rather easily. And now we can see the structure. And all of these features are going to be red because that's the color that's used for the dicer stems. This is 24, 23. Now, occasionally we have to reposition just to keep things in the center. The program doesn't do that automatically. 21, 20. So now we see once again that the structures, there's still some big loops there. 19, 17. So there's no 18, for example. So we can pick the center again and rotate around the center rather nicely. Here's 16, 15. Oh, no, see, that's gone off. And off the picture. So we have to recenter. And then we'll resume. And so you see here's the structure with 15 base stems resolved. 14, 13, 12. I'll recenter again. So you can see the graphic is really rather beautiful. 11. Let's go to 10. I'll recenter again. Zoom up a bit. So here you see the structure is getting very much more complex now because there are lots of little loops that are being formed by those bases that are 10 or more. 9. Again, I have to reposition this, failing in the program. 8. 7. So now, pick again. Now you see the structures are getting quite well defined. 6, 5. Again, I'll pick the center and zoom up a bit. And so now you can see the structure developing here. And then 4 and 3. Oh, see, this jumps off the screen too. And then finally 2. So I'll pick again to find a nice center. And so now we see the structure has definite regions. And so what you see is that the dicer stems form in ways that separate the structure into a variety of different domains. So for example, all of this structure up here is one domain, and all of the structure here is one domain, and all of the structure here is one domain. And so this is something that you could only understand by running the FASTA algorithm, and then using the graphic to look at the spatial positioning. It's quite elegant.